This lesson is going to cover something called the real number line, or most of you would be familiar with calling this just simply the number line. Numbers used in algebra are typically real numbers until you get about halfway through Algebra 2, and then we introduce some other kinds of numbers, and it's always a mystery. I actually have some t-shirts for numbers that aren't real, that up until this point in your math and for quite a while after now, like all the numbers that you'll deal with are what are called real numbers. And what we can do is we can plot these numbers on a line. Okay, it's a horizontal line, and typically we think of 0 as being in the middle of that line. Sometimes that is called the origin. Origin means like the starting or the beginning of something, and so you think of like counting your numbers, you start at the origin. It's like 0, or when we get to the coordinate plane, it'll be like 0, 0. And then as you move to the right on the number line, you count upward in integers, and you can scale your number line by different things if you need to. And to the left, you have negative integers. And pretty much what the number line is it is a way to picture numbers. It's not an end game. The number line is not an end game. Even though sometimes in a math class, a teacher might have you construct a number line or construct some kind of graph on a number line as an answer to a question on a test or something, it's never really the end of what you're trying to study. The number line is always a tool for being able to conceptualize or visualize relationships that aren't necessarily easy to visualize on its own. These numbers that I've plotted here are what are called the integers. In math, we sometimes call these the friendly numbers. These are the nice numbers, the numbers that you want to have come out as the answers. Even better if they're positive, but we can handle them if they're negative as well. And we can use the number line to graph these numbers or other numbers. So for example, this isn't typically what you would be asked to do, but like somebody might say graph the number 3 or plot. It might be the more mathy way of saying it, like plot the number 3. And all you do is this. You go over to the 3 and you put a dot at the 3, which probably seems really weird, but trust me, it becomes useful. Okay. The number line is super useful in that we can also do like fractions. So you could do the number 1/2, and the number 1/2 would be halfway between 0 and 1. So even though you don't see a tick mark there, it doesn't mean that there aren't numbers there. In fact, there are an infinite number of numbers just between the 0 and the 1, because you can always go closer together than you are right now. We can do decimals. So we'll do like -2.3. So you want to be careful about this. And this is where a number line can really help. -2.3. So you go -1, -2. We have to go a little bit further than -2. So we have to go a little bit further, and we'll estimate where that is, about 3/10 of the way between -2 and -3. Again, what this does is it creates a visual model of where numbers are, where they are relative to each other. It can help you see relationships between pairs of numbers or sets of numbers, and that's why we make number lines. We make it as a tool. So here's one example where a number line might come in useful. If you're dealing with positive numbers, most of us don't have too much trouble figuring out like 3 is less than 5. Okay, like we've been alive for a while now. Okay, that 3 is less than 5. But when we get to the negative numbers, that can get trickier. So what about -3 and -5? Well, a lot of us, like our instinct, just kind of wants to look at the 3 and the 5 part. And we think, oh, well, the 3 is less than 5, therefore negative 3 is less than negative 5. But it's not. And one of the ways that we can do better at seeing that is to plot it on the number line. So remember, on the number line, the greater numbers are to the right, and the lesser numbers are to the left. And if you have trouble remembering that, just think of the positives. Like if you think of the positives, you'll get the orientation of that right. So bigger to the right, smaller to the left. And it's no different once you cross the other side of the 0. So if I plot the negative 5 and I plot the negative 3, you can tell that negative 5 is less than negative 3. And if we were going to try to put it here, negative 5 is less than negative 3. Notice the orientation of that. It always wants to eat the bigger number. So when I switch the order, I need to switch the orientation of the symbol. So negative 3 is actually greater than negative 5. This is a great way to picture it if you have trouble with your signed numbers, which is a chronic mistake in all of mathematics. So a common type of exercise that a teacher might give you to do is to write the numbers in increasing or decreasing order. So write in increasing order. And then they'll give you a list of numbers. Negative 2, 4, 0, 1.5, negative 1/2, and negative 3/2. Awesome. And so what they're trying to do is to get you to realize how numbers are related to each other. When are you dealing with like bigger numbers, smaller numbers? This skill will come in very handy when we start operating. So we're going to do in this unit a lot of operating with our signed numbers, which will eventually turn into operating with signed numbers within equations. And the better you develop a sense of like the size of numbers, the easier that will be. So we're going to write these in increasing order, which would be from left to right on the number line, by plotting them on the number line, and then we can just read them off. So I'm going to go ahead and plot negative 2. I'll put a little check mark next to it when I do it. 4, which is way over here to the right. 0, which is my favorite number. All my students know it's my favorite number. 1.5, so that's 1 and 5/10. So that's going to be halfway between 1 and the 1.5. Negative 1/2, so negative means we're going to the left, but we don't want to get all the way to the negative 1. We only want to go half of the way. And then negative 3/2. So we got to think about that. So here's 1/2, 2/2, 3/2. Right there. Okay, so here are our numbers in increasing order. Negative 2 is the smallest. Negative 3/2, negative 1/2, 0, 1.5, and 4. And the number line just is a useful tool, and all it's doing there, it's not the end game, okay? It's not the final goal. It's a way of ordering the numbers so that we have a sense of not only just which ones are smaller and which ones are bigger, but like how much bigger are they? Are they like a little bit bigger, or are they a lot bigger or a lot smaller? And so number line really, really can help with that. Okay, next topic in this lesson is the idea of opposites. Okay, and opposites in math are the same distance from the origin or from 0, but on opposite sides. So opposites are numbers that are the same distance from 0, but on opposite sides of the number line. So for example, okay, so we'll keep doing our number line here. I would not have made it through grad school without a number line. I'm just going to be really honest about that. We did a lot of weird things with weird sets of numbers, and the number line was very useful. So here's my origin, okay? I'm going to put a dot there. That's the origin, that's your 0. And I can go distance in either way. So I'm going to go 3 units, okay, out. So when you're counting units, make sure you count spaces and not tick marks. So I'm counting 1 space, 2 space, 3 spaces. And that puts me at the 3. Now, I can also count the same distance in the other direction. Because remember, opposites are numbers that are the same distance from 0, but on opposite sides. So I went 3 units to the right. Now I'm going to go 3 units to the left. 1, 2, 3. And notice that this is 3 units. And this is also 3 units. So they are the same distance, but going in different directions. So 3 and -3 are opposites. Okay, so what are some things about opposites? So the symbol for opposite is, symbol for opposite, I do this with my Algebra 2 kids, is that, which probably looks like a negative sign or a minus sign or a subtraction symbol. And you would be correct in all of those, okay? Because it's all the same symbol. So that's, yeah. So here, let's just kind of get to this. So if A is equal to 5, all right? Then, now I'm going to read this a very specific way. The opposite of A is equal to -5, or the opposite of 5. So just let me say that again, okay? If A is equal to 5, then the opposite of A is the opposite of 5. Now you might say, well, that's kind of weird. Why don't you just say -5? I think I did it the first time. So the words are interchangeable, opposite and negative. If A is equal to -6, then the opposite of A is the opposite of -6. But what's the opposite of -6? Here's 0, here's -6. What number is on the opposite side of the 0, but the same distance away? You might think that would be 6. So the opposite of -6 is 6. So that double negative is like the opposite of the opposite. It takes a little bit to get your head around that. So let's summarize that, okay? If A is positive, and I'm just going to represent positive by the little plus sign in there, then its opposite is negative. If A is negative, then its opposite is positive. So for example, like you could have 4 and its opposite is, let me use a better notation. Its opposite, -4. If you have -6, oh, we already did -6. Let's do -3.5, then its opposite would be +3.5. And then the last part is the opposite of 0 is 0. Okay, so just don't overthink that. Like, there's no such thing as -0. When I first started teaching in my current school district, I had like these 7th graders tell me that 0 wasn't a number and that their previous math teacher had told them that 0 wasn't a number. See, I don't really believe that. I don't think the math teacher said that, but okay. Last little concept for this lesson is absolute value. So this lesson has quite a lot of stuff in it. Absolute value is defined as a number's distance from 0 on the number line. That is the definition of absolute value, and the symbol for absolute value is two vertical lines with something in between them. Okay, so two vertical lines with something in there. There's something, put something in between those two vertical lines. You want to make sure that when you're using absolute value symbols that they don't look like ones. So sometimes if you're a little bit careless with how you write them, they can end up looking like ones. So let's do a couple examples with this. This would be read out loud as the absolute value of -3. Okay, so that's how that vocabulary would be used when you're writing it, the absolute value of -3. So what could the absolute value of -3 be? Well, that's where you want to engage the definition. Absolute value is a number's distance from 0. So if you were to look on the number line and you look at -3, how far away from the 0 is that? Well, I think we actually did that earlier. -3 is 3 units away from 0. So the absolute value of -3 is 3. What about the absolute value of +3? Okay, well, remember the definition. This is why definitions are so important. The absolute value is the distance from 0, which is so on the number line. So how far away is 3 from 0? Well, it is also 3 units away. Okay? Now, what about this one? The absolute value of 0. Well, how far away is 0 from itself on the number line? That would be 0. Sometimes students will slip into the mindset of saying that that absolute value is always positive, which isn't exactly true, because it could be 0. It's always true that absolute value is non-negative, like absolute value can never be negative, but it's not true that it's always positive because sometimes it's 0. Really important definition there. All right, so the next thing is to get some practice. So I'm going to put some practice problems up on the next slide, and then we will go over them together. All right, so here are a few problems. For number 1, use the number line to write these numbers in increasing order, and always be aware of slick directional changes where somebody might say, write these in decreasing order. It's kind of sneaky, but just be aware of it. For number 2, find the opposite of, and then there's 1, 2, 3, 4, 5 numbers there for you to find the opposite of those numbers. And then number 3, evaluate the expression. So there's 1, 2, 3, 4, 5 expressions there. Remember, evaluate just means find the value of. So find what this expression is equal to. And then number 4 is just a more complex one with some absolute values and asking you to integrate that. So pause the video at this point and then unpause it to check your answers. All right, so for this first one, we are using the number line to write these in increasing order. And again, remember that the intent of this is to practice, knowing your numbers. Let's try that again. Is to practice using a tool. It's not like you're going to be making number lines, forever in whatever job you have. Okay, that's just not how this works. But if you're given a problem, if you work for an engineering company or you're a scientist or something and you're given a problem to do, then you might use the number line as a tool in solving it. So 3.1 is going to be out to the 3 and just a little bit past the 3, and it's okay to estimate. That's totally fine. -1.9, so we're going to go negative and then 1, and then 0.9 is going to bring us almost all the way to the -2. 4, so 3, 4, 0, 1/2, okay, 1/2 is going to be in between 0 and 1, and then negative 1/2, which is going to go in the other direction. Okay, and we should be able to list them off. Now we're going to write them in increasing order. So it begins with negative 1.9, then negative 1/2, 0, 1/2, 3.1, and 4. So hopefully you got those right. If not, you want to identify what your mistake is. Next bank of problems is find the opposite of. So the opposite of 6 is negative 6. The opposite of negative 10 is positive 10. The opposite of negative 2.4 is positive 2.4. The opposite of 1.9 is negative 1.9. And the opposite of 0 is 0. So again, check your answers there. Opposite means like flipping the sign. Think opposite sides of the 0. Next one is to evaluate the expression. So that is just assessing whether or not you remember or understand what absolute value is. So the absolute value is distance from 0. So how far away from 0 is 5? It is 5 units away. How far away from 0 is negative 3? It is 3 units away. How far away from 0 is negative 4/5? Don't let the fact that it's a fraction throw you. Math is awesomely consistent. So whatever the definition of absolute value is what the definition of absolute value is. It's not going to change. So the distance from 0 of negative 4/5 is 4/5. It's just in the negative direction. Distance from 0 of 3.2 is 3.2 units away, and the distance from 0, or absolute value, of negative 4.1 is positive 4.1. It's 4.1 units. It's just going to the left. Last little problem. What happened to my last little problem? Okay, well, I don't know what happened there. What is the last little problem? It is the absolute value of 6 minus the absolute value of negative 1. So this goes back to order of operations, and remember that absolute value, well, it maybe not remember, but it is a grouping symbol, and so you want to do what's in the absolute value first. So we'd ask ourselves, what is the distance from 0 of 6? And that would be 6, minus what is the distance from 0 of negative 1? Well, that is 1 unit away, and then 6 minus 1 is 5. I don't give a whole lot of practice problems in these videos because I'm trying to keep them in the vicinity of 20 to 25 minutes long. If you ever need more practice, though, make sure that you're getting it. So if you're making mistakes and you don't feel like you really get the concepts, hunt around online, do these problems over again, make sure that you're getting enough practice.